All right, welcome back to the deep dive. Today, we're going to be diving into something I think you're going to find pretty interesting. We're talking about Nvidia. And, everyone knows them for their, incredible GeForce gaming stuff. But we're going way deeper than that. We're going to explore how they became this AI powerhouse. And the secret weapon, you could say, is something called CUDA. Have you heard of CUDA before?
Oh, yes. CUDA is a pretty big deal these days. It's really fascinating how Nvidia, a company known for these incredible visuals, stunning graphics and all that, ended up playing such an important role in something as complex as AI.
Right. Like you think of gaming, you think of, entertainment, but AI, that's like serious stuff. So how did they even get there?
Yeah.
Let's rewind all the way back to their early days, like back to 1993. What was their main focus back then?
So back in 93, they were laser focused on graphics chips, specifically for the booming multimedia and gaming market. This is the time when, PCs were becoming more and more powerful, and everyone wanted richer visuals. More immersive gaming experiences.
Makes sense. But I mean, when we think of Nvidia today, we think of, the top dog. Did they just like explode onto the scene back then?
Actually, no, not at all. They had their fair share of struggles early on. Their very first product, the NV1, it was a total flop.
Oh, wow. Really? That's hard to imagine. Like Nvidia, the giant of graphics, stumbling right out of the gate. What went wrong there?
Well, the NV1 was based on this new technology called quadratic texture mapping, which was pretty radical at the time. But the problem was, it wasn't compatible with the industry standard.
Oh, I see. So they were kind of ahead of their time.
Yeah.
But also maybe a little too far ahead.
Yeah, exactly. It was a bold move.
Yeah.
But it just didn't pay off.
So it's a good reminder that even these, giant tech companies, they're not immune to taking risks. And sometimes those risks just don't work out. But Nvidia, we know they're known for being pretty resilient. How did they bounce back from that?
Well, they learned from that mistake. Adapted quickly. And in 1997, they launched the RVA 128, which delivered really solid performance at a competitive price. That's what really put them on the map.
The RVA 128. Okay, so that was the turning point, gave them that foothold. And then just a couple years later, they really shook things up with the GeForce 256.
Exactly. The GeForce 256, launched in 1999, is widely considered the birth of the GPU as we know it.
The birth of the GPU.
Yeah, it wasn't just a faster graphics card. It was a fundamental shift in how we process visuals. Think of it this way. Before the GPU, the CPU was handling everything. It was like a one-man band trying to play all the instruments at once, running the operating system, processing complex graphics, you name it.
Okay, so it was doing too much.
Way too much. And then the GPU came along. It was like bringing in a whole orchestra. Each instrument specialized for a specific task.
Ah, I like that analogy.
So suddenly the CPU is freed up.
Yeah.
And we could have much more complex and realistic visuals.
Okay, so this is key for our listeners. This is where we start to see why GPUs are so crucial for AI later on. It's all about that parallel processing power, right?
Precisely. GPUs, with their thousands of cores, can perform many calculations simultaneously. That's perfect for graphics where you need to render millions of pixels at once. And as it turns out, it's also perfect for AI, which relies on processing massive amounts of data.
Okay, but before we jump ahead to AI, let's stick with the early 2000s for a bit. So Nvidia is battling it out for dominance in the gaming world. Who were their main rivals at this point?
Their biggest competitor back then was ATI Technologies, which later became part of AMD. The rivalry was fierce, both companies constantly pushing the boundaries, innovating like crazy. It was like a high-stakes chess match.
So it wasn't just about building the best chip, it was about understanding the market, anticipating trends, and just making the right moves.
Exactly. And Nvidia, under the leadership of Jensen Huang, they were incredibly good at playing that game. They were aggressive in acquiring key technologies, like when they acquired 3DFX in 2000. A real pioneer in 3D graphics.
Yeah.
And they were masters at building relationships with game developers, making sure that NVIDIA GPUs were the go-to choice for all the hottest new games.
So by the mid-2000s, they had solidified their position, top of the gaming world. But then something really interesting happened. They decided to take a gamble that would change the trajectory of the company, and arguably the entire tech industry.
And that gamble, my friend, brings us to the story of CUDA.
Okay, so that sets the stage for us. Nvidia at the top of their game, but with a CEO who seems to always be looking ahead, thinking bigger.
Yeah, Jensen Huang, he's a visionary. While the rest of the world saw Nvidia as a gaming company, he saw something more. He saw the potential of GPUs to become the engine of general-purpose computing, capable of tackling problems far beyond just graphics.
All right, so this is where things get really interesting. We're going to dive into CUDA itself in part 2 and how it started to unlock that hidden potential. Stay tuned. All right, so we left off with Nvidia, kind of at a crossroads, right? Dominant in gaming, but with this CEO who saw a much bigger picture for GPUs. This is where CUDA enters the story.
Exactly. In 2006, Nvidia launched CUDA, short for Compute Unified Device Architecture. It was a bold move. You could even say it was a gamble.
Yeah.
Because it wasn't about making GPUs better for gaming. It was about making them accessible for all sorts of complex computations.
Okay, so how did it actually work? Like, was it just a software update or?
It was a fundamental shift. Before CUDA, programming GPUs was incredibly difficult. Like, imagine trying to write a symphony for an orchestra where each musician speaks a different language.
Wow, yeah, that sounds pretty impossible.
Pretty much. But CUDA changed that. It provided a way for developers to use familiar programming languages, like C, to harness the parallel processing power of GPUs.
So it's like CUDA was this universal translator, allowing developers to finally communicate with these powerful processors.
Yeah, that's a great analogy.
So suddenly all these thousands of cores in a GPU, they weren't limited to just rendering pixels anymore.
Right. They could be used to solve complex equations, analyze massive data sets, run simulations, all at speeds that were previously unimaginable.
That's pretty amazing. They basically unlocked this hidden potential that was just sitting there in all these graphics cards. But was the world ready for it? Did developers just like jump on board immediately?
Well, initially the adoption was a bit slow. It was mostly researchers and scientists in fields like physics, chemistry, bioinformatics, who really recognized the potential.
Because they were already dealing with huge data sets and complex calculations.
Exactly. For them, CUDA was a game changer. It allowed them to accelerate their research significantly.
So it was like this quiet revolution brewing in the scientific community.
Yeah, you could say that.
But CUDA hadn't really broken into the mainstream yet.
Right. But the seeds were sown.
And what really brought CUDA into the spotlight was the rise of artificial intelligence.
Exactly. Specifically deep learning.
Ah, deep learning. The technology behind everything from self-driving cars to, those recommendations you get on Spotify.
Pretty much.
But what made deep learning so perfect for CUDA and GPUs?
Well, deep learning models are essentially complex mathematical functions with millions, even billions of parameters. Training these models requires feeding them enormous amounts of data and performing trillions of calculations.
That's intense.
It is. It's a computationally intensive process. That would take traditional CPUs days, weeks, or even months to complete.
So they had the algorithms, they had the data, but they didn't have the computing power to really make deep learning work.
That's right. They were hitting a wall.
And CUDA and GPUs came to the rescue.
Exactly. Remember that parallel processing power we talked about? Well, it turned out to be the perfect solution for deep learning.
Because GPUs, with their thousands of cores, could just crunch through those massive calculations.
Yeah, much faster than a CPU could.
So this feels like a real turning point. It's like the missing piece of the puzzle. Was there like a specific event that really showcased the power of CUDA and GPUs for deep learning?
There was. In 2012, there was this competition called the ImageNet competition. It's an annual challenge where researchers test their image recognition algorithms. And in 2012, a team from the University of Toronto, led by Alex Krasewski, submitted an entry called AlexNet, which was a deep learning model that achieved an unprecedented level of accuracy.
AlexNet, I've heard of that. That was a big deal.
Huge deal. What set AlexNet apart was that it was trained using Nvidia GPUs and CUDA.
Oh, okay.
It demonstrated for the first time the sheer power and efficiency of this approach. It wasn't just a small improvement. It was a giant leap forward in accuracy, and it completely changed the AI landscape.
So this was like the proof of concept that the world had been waiting for. It was clear that CUDA and GPUs could power real-world breakthroughs in AI.
And from that point on, it wasn't just academics and researchers using CUDA.
It was everyone.
Pretty much. AlexNet's victory was a watershed moment. It signaled the beginning of the deep learning revolution.
And Nvidia was in the perfect position.
They were ready.
They weren't just selling GPUs anymore. They were providing the key ingredient for this whole new era of AI.
Exactly.
And they didn't just sit back and watch it happen.
No, they didn't.
They made some really smart decisions.
They were very strategic.
That solidified their position in the AI world.
They realized that just having the best hardware wasn't enough. They needed to build a whole ecosystem to support this growing community of AI developers.
Okay, so this ecosystem approach sounds interesting. In part 3, let's break down how they went from a hardware company to this AI powerhouse, shaping the future of the field.
Okay, so we're back, ready to unpack this final piece of the Nvidia puzzle. We've seen them go from, gaming giants to these AI pioneers. But what did it actually take to build this AI ecosystem? What were the pieces they put in place?
Well, it really shows their vision. They knew that the future of AI wasn't just about raw power. It was about accessibility,
Yeah.
ease of use, and creating a platform that could really empower developers across tons of industries.
So it's less about just selling chips and more about, fostering this whole community.
Yeah, exactly.
Can you give us some examples? Like, what were some of the key components of this ecosystem they built?
Okay, so on the hardware side, they kept pushing the boundaries with AI-specific GPUs, like the Tesla series, designed for the heavy lifting of deep learning.
Tesla.
And then they introduced DGX systems, which are basically supercomputers in a box, preloaded with software, and optimized for AI.
So they were providing both the raw power and these ready-to-go solutions for serious AI development. But what about the software side? We talked about CUD, but did they kind of build on that foundation?
Oh, yeah, absolutely. CUDA was just the beginning. They developed specialized libraries like CUDA, which specifically accelerates deep learning tasks. And then there's TensorRT. It's a powerful SDK that optimizes trained AI models for deployment.
For deployment.
So it makes them run faster and more efficiently.
Okay, so they were thinking ahead, anticipating what developers would need, not just to build AI models, but to actually put them to work in the real world.
Exactly. And they didn't stop there. They realized that AI wasn't one size fits all. Different industries had different needs.
Of course.
So they developed these targeted SDKs, like DriveWorks for autonomous vehicles.
DriveWorks.
And Clara for healthcare and medical imaging.
Okay, so they were tailoring solutions for specific applications.
Yeah, making it easier for developers to get started and actually see results.
This all sounds incredibly strategic.
It was. And another brilliant move was embracing cloud computing.
The cloud!
They partnered with major cloud providers like AWS Azure and Google Cloud, so their GPUs and the CUDA platform became available to a much wider audience.
That's huge. So developers could access all that power without having to buy and maintain all that expensive hardware.
Exactly.
It democratized AI development.
You got it.
Okay, so we've seen how they built this incredible AI empire. They had the foresight, the technology, the partnerships. But let's bring it back to our listener for a second. Why should they care about this story? What's the takeaway?
Well, the impact of CUDA and Nvidia's AI ecosystem is literally everywhere. Think about the things you use every day. Your smartphone's voice assistant, personalized recommendations online, spam filters, even medical diagnoses and treatments are being transformed by AI.
So CUDA is kind of this hidden force
Yeah.
behind so many innovations.
Exactly.
And it's not just about convenience.
Right. AI is being used to tackle some of the world's biggest challenges. Climate change, disease prevention. And Nvidia's technology is accelerating these advancements.
It's pretty mind-blowing, from making video games look better to, potentially changing the world. But what about the future of CUDA itself? Where do you see this technology going?
Well, AI is constantly evolving. The demand for more and more computational power is only going to increase. Nvidia is already exploring new architectures, pushing the limits of performance and efficiency. Quantum computing is on the horizon. Who knows what breakthroughs are coming next?
Quantum computing, now that's a whole other deep dive.
For sure.
But the point is, NVIDIA's not standing still. They're always innovating. And CUDA will undoubtedly be a key part of that. So for our listeners, the story of CUDA is far from over. It's just getting started. And we've only scratched the surface here. There's a whole universe of AI and computing out there to explore. Thanks for joining us on The Deep Dive.